Good morning, students. This is paper first. Title is Microcontroller Architecture and Programming. We had already discussing about the syllabus, credit pattern, and etc. Other things we had already mentioned in last lecture. This is our unit first, whose name is Basics of Microcontroller and Intel 8051 Architecture. Content of this chapter. First is microprocessor and microcontroller. Second is introduction of microcontroller. Third one is a block diagram. Fourth one is a architecture of 8051. Fifth one is internal RAM organization. Sixth, pin diagram. Seventh, connection diagram. Eighth number, input output port structure. And last, interfacing to external memory. An embedded system uses either a microcontroller or microprocessor to perform a single task. Mouse, printer, remote control of TV are the example of embedded system. Then what is the question? Microprocessor and microcontroller. What is microprocessor and what is microcontroller? A microprocessor does not have any RAM or ROM and no input output ports on the chip itself. And on microcontroller these all are present: RAM, ROM, input output ports. However, a microcontroller has many of these features. It is a computer by itself, so a microcontroller is also called a single chip microcomputer. A microcontroller can differ from one another on the basis of its data word size, technology used for its manufacture, its architecture, presence or absence of memory, presence of serial and parallel ports, speed of operation, and so on. This is the actual definition of microprocessor and microcontroller. Microprocessor is an IC which has only the CPU inside them, that is only the processing power such as Intel Pentium 1, 2, 3, 4, Core 2 Duo, i3, i5, etc. Second is microcontroller. Microcontroller has a CPU in addition with a fixed amount of RAM, ROM and other peripherals all embedded on single chip. A microcontroller is normally used for specific applications. A microprocessor can be used for various types of application by adding appropriate amount of memory and input output ports. They are versatile. Since a microcontroller has a built-in memory and ports, they are most suitable for applications where cost and space are critical. Some microcontrollers have on-chip ADC and other peripherals. A microcontroller has limited expansion in terms of memory and input output ports externally. They are cheaper and consume less power. This is the block diagram of microprocessor and microcontroller. In this block diagram we can see in microprocessor there is only control unit ALU. ALU stands for arithmetic and logical unit. Then CPU means central processing units. Then registers, this is different registers. Registers, registers. Registers means memories or storage device. Microprocessor have address bus, data bus and control bus. This is the common. Then second is microcontroller. Microcontroller contains CPU, input output ports, RAM, ROM, counters, timers, and address data bus and control bus. This is the difference table: microprocessor and microcontroller. Microprocessor has microprocessor has external circuits which are connected, namely ROM, uh, read write memory, serial interface, timer, input output ports. These are the external circuits. Microcontroller, in addition with read only memory, means ROM, read write memory, timer, input output ports, and last is serial interface. Serial interface uses used for serial communication. Second difference is microprocessor is the heart of computer system, and microcontroller is the heart of embedded system. Third one is it is a just processor. Memory and input output components have to be connected externally. Third difference of microcontroller is microcontroller has external processor along with internal memory and input output component. Fourth one is since memory and input output has to be connected externally, the circuit becomes large. Obviously, external connection is interfaced, then circuit is become large. Circuit becomes large. Microcontroller, since memory and input output are present internally, the circuit is small. Okay. Fifth one, cannot be used in compact system and hence inefficient. Efficiency is less or negligible. Can be used in compact system and hence it is an efficient technique. It is efficient. Sixth one is cost of the entire system increases, obviously, because external circuits as like memory input outputs are connected, so that's why cost is increases. Cost of the microcontroller's cost is low. The next is due to external components the entire power consumption is high. Since external components are low, total consumption power is less. Most of the microprocessors do not have power saving features. In microcontroller, most of the microcontrollers have power saving modes like idle mode and power saving mode. This helps to reduce power consumption ever further. Next is most since memory and input output components are all external, each instruction will need external operation, hence it is relatively slower. All the external circuits are connected, so that's why instruction also slow, and relative operations speed is slow. Since components are internal, most of the operations are internal instructions, hence speed is fast. Speed of microcontroller is fast. Microprocessor have a less number of registers, hence more operations are memory based. Microcontroller have a more number of registers, hence the programs are easier to write. Microprocessors are based on von Neumann model, and microcontrollers are based on Harvard architecture. Harvard and von Neumann. This is the types of architecture which we will be explaining in next PPT. Next slide. Last is mainly used in personal computers. In microcontroller, used mainly in washing machines, MP3 players. Means microprocessor is relatively useful in computer system, and microcontroller is application based as like washing machine, MP3 players, etc. Now, introduction to microcontroller. Microcontrollers usually must have a low power requirement since many devices they control are best battery operated. Control are battery operated. Microcontrollers are used in many consumer electronics, car engines, computer peripherals, and test or measurement equipment. And are these are well suited for long lasting battery applications. The classifications of microcontrollers according to number of bits. The bits in microcontrollers are 8 bits, 16 bits, and 32 bits. 2 raised to n means 2 raised to n power. In 8-bit microcontroller, the point when the internal bus is 8-bit, then the ALU is performs the arithmetic and logic operations. The example of the 8-bit microcontrollers are Intel 8031 oblique 8051 PIC 1X. X means any number, and Motorola MC68 HC11 families. In this paper first 8051 microcontroller, this is the 8-bit microcontroller whose internal bus size is 8-bit and its allow performs arithmetic and logical operations. Arithmetic means addition, subtraction, division, multiplication, etc. And logical operations means and, NAND, OR, XOR, etc. Second one is the 16-bit microcontroller performs greater precision and performances as compared to the 8-bit. Some examples of 16-bit microcontrollers are 16-bit MCU machine control unit are extended 8051XA PIC 2X or 2 cross Intel 8096 and Motorola MC68 HC12 families. Third one is the bit. The 32-bit microcontroller uses the 32-bit instruction to perform the arithmetic and logical operations. These are used in automatically controlled devices including implantable medical devices, engine control system, office machines, appliances and other types of embedded system. Example of 32-bit microcontroller is Intel or Atmel. Intel or Atmel is this is the manufacturing companies. 251 family and PIC 3 cross. Comparison between 8051 family members. The following tables compares the features available in 8051, 8052 and 8031. This is the most important table. In exam, many questions are arrived on this table in MCQ or in one sentence, one line answer, one sentence answer. Table contains features: ROM, RAM, timer, input output pins, serial ports, interrupt sources. Families of 8051 is 8051, 8052, 8031. ROM of 8051 is 4K, 4 kilobytes. 8052 is 8 kilobytes and 8031 is 0 kilobyte. RAM RAM of 8051 is 128 bytes. RAM of 8052 is 256 bytes and RAM of 8031 is 128 bytes, same as 8051. Timers 8051 has two timers. 8052 has 3 timers and 8031 has 2 timers. 8051 had has in 32 input output pins. 8052 has 32 input output pins, and 8031 has also 32 input output pins. Serial port present in 8051 is 1, same in 8052 and same in 8031. Last is interrupt sources. 8051 has 6, 8052 has 8, and 8031 has 6. Features of 8051. This will also ask in exams. Anyone or 2-mark question. Explain the features of microcontroller. 8051 microcontroller. First is 4 kilobyte on chip program memory, that means ROM memory. Second one is 128 bytes on chip data memory, that is RAM memory. Third is 4 register banks, namely RB0, RB1, RB2, RB3. Fourth one is 128 user defined software flags. Fifth one, 8-bit bidirectional data bus. Sixth one, 16-bit unidirectional address bus. Data bus and address bus. Data bus which carries data, and address bus which carries addresses. Addresses means locations. Next is 32 general purpose register, each of 8-bit. Each register's size is 8-bit. Next is 16-bit timers, usually 2, but may have more or less. Next is total 6 interrupt, that will be classified into internal interrupt and external interrupt. Next is a 4 8-bit ports. Short model have 2 8-bit ports. In 8051 there is a 4 ports: port 0, port 1, port 2, port 3. Next is 16-bit program counter and data pointer. The program counter and data pointer has size 16-bit. Last is 8051 may also have a number of special features such as UART, ADC, and UART stands for Universal Asynchronous Receiver Transmitter. ADC stands for Analog to Digital Converter. Op amp, operational amplifier.